So what is this linear span? Let me just write out the definition first. Consider a set of vectors. Consider set of vectors v1, v2 up till vk belonging to say Rn, and consider scalar real numbers a1, a2 up till ak belonging to the set of real numbers. What is a linear combination of a? Linear combination. A linear combination is nothing but a1 v1 plus a2 v2 plus up till ak vk. This is known as a linear combination of the set of vectors v1, v2 up till vk. This is a linear combination right here with coefficients a1, a2, ak respectively. So this linear combination stuff is pretty clear. Moving on to what is linear span. If we vary the set of coefficients, we get the linear span of set of vectors v1, v2 up till vk. This is the linear span of the set of vectors. Now this might be a little confusing right now. So let me just take an example. Like let's just take say R3 to clear this up. Let's take R3 to clear this up. Say I have a coordinate system. Now we must remember coordinate systems from our younger days, right? So this is a coordinate system. Let me consider three vectors v1, v2 and v3 like this. See, these are three vectors from the origin all in different directions. So now what is a linear combination of v1, v2, v3? What is a linear combination? A linear combination is nothing but a1, v1 plus a2, v2 plus a3, v3. So these are real numbers and these are vectors. But now what is the linear span of v1, v2, 3? The linear span of v1, v2, v3 is the whole of R3. This is very important to understand. Why am I saying it's the whole of R3? Because if you vary this coefficient a1, this vector will stretch and squeeze. Like say if a1 is equals to 1, then it will remain here. If a1 is equals to 2, then the vector v1 will multiply twice in its size and come here. This will be v1. If a1 is equals to 1 by 2, it will shrink by half its size. If it's minus 1 by 2, it will go in the opposite direction. So it covers a line here. Now when we add v2, which is not in the same direction as v1, in a certain sense it's not dependent on v1, very important here, we are doing the same thing and creating a plane out of these two. So when we vary these coefficients, the points that these two vectors will cover will form a plane in R2. But what will happen next? When we consider the next vector, say we consider it here, let's say v3, and this vector is also not dependent on v2 or v1. So what is happening here? What's happening here is that this plane is being given a dimension of height. So in a sense, it is covering the whole volume of R3. So that is the linear span of these three vectors. So it's a hand-wavy definition, but it's very important to understand what R3 is here. So this is the definition of linear span and linear combination. So it's very important.